In the question number 10, we have to follow the instruction. Okay, let's start with the first one, that is the rational number that does not have a reciprocal. We have to write down a rational number. Okay, so by that the condition is there should not be the reciprocal for that number. Let's see. If I just write 0, let's find out the reciprocal of 0. Okay, so it can be written as 1 by 0, but that is not possible in mathematics. Okay, we have already discussed that 1 by 0, that is actually the error, that's not the valid number in the maths. Okay, we cannot do reciprocal for 0. Now let's do the second one. In the second one, the statement is given that the rational number that are equal to their reciprocal. Okay, we have to find out the rational numbers whose reciprocal is equal to that only. So 1. Okay, let's find the reciprocal of 1, that is 1 upon 1 only. So again, that is 1. Done. Then another one I can say that is minus 1. For the minus 1, that is again the same thing. If I will write down the reciprocal of minus 1, it will be 1 upon minus 1. Okay, again 1 1, so that is 1 only, and here minus sign, that's minus 1. So reciprocal of 1 and minus 1, that is always same as 1 and minus 1. So there is no change. Okay, so both are same. Now third one, the statement given, that is the reciprocal number that is equal to its negative. Okay, a number which is equal to its negative. Like for example, if I just select 1 by 5, so its negative is minus 1 by 5. Are they equal? No, because 1 by 5 and minus 1 by 5, we can never say that they are equal. Only one number is there, that is 0. Okay, because plus 0 minus 0, that is always 0 only. There is no any changes. So this is the question number 10. Just pause the video and note it down. Now the last question of this exercise, that is question number 11. Okay, and that is fill in the blanks. So let's start with the first one. That is 0 has blank reciprocal. Okay, so it means 0 has how many reciprocals? So 0 has actually no reciprocal, as we have already discussed in the last question. So 0 has no reciprocal. 0 has no reciprocal. Then the second one, that is, or you can write 0 has 0 reciprocal, whatever. The second one, that is the numbers blank and blank are their own reciprocal. So we have to write down the numbers whose having the reciprocal, they are always same, like 1 and the 1, minus 1 and minus 1. Okay, reciprocal of 1, that is 1 only, and minus 1, that is minus 1 only. The same question we have discussed in the last question. So that is 1 and minus 1. Okay, now the third one, that is the reciprocal of minus 5. Reciprocal of minus 5 is 1 by minus 5. Okay, that is 1 by minus 5. Reciprocal of minus 5, that is 1 by minus 5. Then the fourth one, that is reciprocal of 1 by x. Reciprocal of 1 by x, where x is not equals to 0. Why this condition is written over there? Because suppose here x is a number. Now if we take that x is equals to 0, at the time that will be 1 by 0. But in the mathematics, 1 by 0, that is not the valid term, that is error actually. So we have to just give the consideration that where x is not equals to 0. Now we have to write down the reciprocal of 1 by x, that will be x only. Okay, the process is always same. Just we will shuffle the numerator and the denominator. Here x is the denominator, so that's the numerator, and 1 is numerator, that's the denominator. But 1, there is no need to write 1 in the denominator. That's why we didn't write. Fifth one, that is the product of two rational numbers. Product of two rational numbers, it means multiplication of the two rational numbers is always there. So if I just do the 1 by 5 multiplied by 1 by 6, answer will be 1 by 30. So again 1 by 30 is what? That is again the rational number only. So multiplication of or the product of two rational number, that is always a rational number only. A rational number only. Rational number only. Then the last, the sixth one, that is the reciprocal of a positive rational number is positive only. Because reciprocal of 1 by 5, that is 5, 1 by 7, that is 7, reciprocal of 10, that is 1 by 10. So whenever we choose any positive rational number, and if we do the reciprocal of that rational number, that is always positive. So here we have completed the exercise 1.1. Now it's time for your work, because practice makes perfect. So today you have to complete this whole exercise 1.1 again by yourself only. Okay, now just pause the video and note it down. Now we are going to learn about how we can represent the rational numbers on the number line. But before we just learn about the rational numbers, first of all, let's see how we can just represent the whole numbers, natural numbers, as well as integers on the number line. That you know very well, but let's revise that first of all. Here I have one, this is the another one, here another one, okay, and one more. So let's start with the natural numbers. Okay, a natural number starts from 1, 2, 3, 4 like that. Okay, all the positive numbers, but we will not include 0 in the natural number. It means just we have to start from the 1 only. It means from the left hand side. From the left hand side there is no number. So it starts from 1 only. So here that's the 1, then 2, 3, 4, 5, 6, 7 until the infinite, but plus infinite. Okay. Till the plus infinite. Now, after natural number, let's see the whole numbers. In the whole number, we just start with the 0. 0, 1, 2, 3, 4 like that. Okay. So it means there is the initial one, that is the 0, and then till infinite. So again, there is on the left hand side there is no number after 0. So here we will start from the 0 only. 0, 1, 2, 3, 4, 5, 6, 7 until plus infinite. Okay. In natural number and the whole number, there is only one single difference, that is the 0. Okay. So almost the number line will be same, but in the whole number we have to include 0. So we will just start with the 0, and in natural number we will start from 1. Now after that, the integers. Okay, Z. Integers. In the integers, how we can do? Integers, it means all the positive, all the negative, and the 0. So it means on the middle one there is 0, on the middle one there is 0, on the right hand side all the positive numbers. So 1, 2, 3, 4 till infinite, positive infinite. As well as on the left hand side there will be the negative numbers, so -1, -2, -3, -4 till minus infinite. Okay. So this is all about the integers. Now comes the rational number. Rational number, actually rational number, it means we know very well that what is rational number now. That if any number that is in the form of P by Q, in the form of P by Q, okay, they all are known as the rational numbers. So simply the number which is in the fraction form. But first of all, I am just going to show you the simply from the integers to rational number how we can convert. So here like 0, 1, 2, here is -1 and -2. Okay, and here is plus infinite, and this side minus infinite. Now, if I just want to represent, we cannot identify anywhere that we can where we can put the fraction, because here is 0, then 1, then 2. Here is -1, -2 in between. No number is missing in between 0 and 1 and 2. Okay, and here is still infinite, so again no number is missing. But rational number, it means the fraction from like 1 by 2, like 1 by 2. So 1 by 2, that is actually the middle point of 0 and 1. 1 by 2, it means half. 1 by 2 can be written as 0.5 also. So actually 1 by 2 will come here. This is the point 1 by 2. Okay, so this is the rational number. This is like this. We can represent the rational number. In the brief, we will go, but before that, just pause the video and note it down. Here we have 3 lines. Okay, on that we are just going to represent the rational numbers. So that will be the number line for the rational numbers. So let's see how we can. Okay, on the first one, I am just going to represent the rational numbers randomly. Okay, not any fixed one. So if I just start with the 0, so here is 0. Okay, and let me select the parts 1 by 5. So after here I can say 0 by 5, then 1 by 5. This is 2 by 5, 3 by 5, 4 by 5, 5 by 5, and as well as here is 6 by 5. Okay, and you can observe that here these all are the rational numbers because these all are in the form of P by Q form. Okay, all are in the fraction form. Now on the left hand side again we can represent the negative also because negative numbers are also known as the rational numbers. Okay, not all the but which are in the form of minus P by Q, they all are in the form of negative rational numbers. So simply I can do minus 1 by 5, minus 2 by 5, minus 3 by 5, minus 4 by 5, and here that's minus 5 by 5. Okay. Now let me tell you one very interesting thing that here we can identify that all are the rational numbers, but in between there are some whole numbers or some integers are also there. How? See, 0 by 5 that can be written as 0 only because 0 divided by 5 that's 0 only. 1 by 5, 2 by 5, 3 by 5 and 4 by 5 that's okay. Okay, that will be remain as it is, but again 5 upon 5, the number divided by itself that is 1 because 5 divided by 5 that is always 1, so here we having the 1. As well as here that is minus 5 by 5. If I do minus 5 divided by 5 that will be minus 1. Okay. So here actually what we did, we just make the path in between the 0 and 1 and as well as this side 0 and minus 1. We just converted into parts of the number line. If you convert into the parts, that will be the actually the representing of the rational numbers as we did here. Fine. But this is the actually the general form. But sometimes if I ask you that represent 7 upon 3 on the rational number, 7 by 3 on the rational numbers, how we can do? Here see, if I am asking you that represent 7 by 3 on the number line. Represent 7 by 3 on the number line, how we can represent that? So for that, just always remember that, see the denominator, what is that? That's a 3. So here as we make the denominator same, here just see that, all the denominators are 5. So whenever you are going to represent a particular rational number, first of all check the denominator of the rational number, as here we have taken an example that is 7 by 3 and the denominator is 3. So for whole rational number, so for whole number line, we will put the rational numbers with the denominator 3. See how? Simply let's see here, that's a 0. Okay, on the negative side, on the left hand side, they are all are negative numbers. So minus 1 by 3, minus 2 by 3. As I told you that we will just take the rational numbers having the denominator 3. So there is no any change. Simply we have to go till 7. So we will move like 1, 2, 3, 4, 5. But in denominator we will write 3. So here 1 by 3, 2 by 3, 4 by 3, 5 by 3, 6 by 3, 7 by 3, 8 by 3, and 9 by 3. Okay. Now just find out 7 by 3 on the number line. Where is that? Here is the 7 by 3. So just I am going to do a circle on that. So here the representation of 7 by 3 on the rational number on the number line that is completed. So this is how we can represent the rational numbers, particular rational numbers on the number line. And again, see the one thing that as you can see here, that is the 0 can be written as 0 by 3. Okay, here is 3 can be written as 0 by 3. So that's the 0 by 3. Now just again see something is here is actually 3 by 3 which is missing. Here is 3 by 3. Let me just correct that. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 as well as then minus 1, minus 2. Okay. So just be clear again. you have to start with 0, 1, 2, 3, 4, 5 till like that only. Okay, do not miss any numbers. By mistake I just missed the one number which is already written now. Again, now see the magic, that 3 by 3. Okay, 3 by 3 means that is 1. Okay, because 3 divided by 3, the number divided by itself, that is always 1. Here 0 by 3 which is again 0. Now here 6 by 3 that is 2, 9 by 3 that is 3. So whenever you are representing the rational numbers, the integers are always there, but you have to just identify that. And here we are just dividing by 3. It means what we are doing? We are just making the parts by 3, 3, 3. Okay, we are making the part by 3. See here. Let's start from 0. This is the first part. This is the second part. Okay, and this is the third part. Okay, so after each and every integer you will find 3 parts. Here you will find 5 parts. See here. 1, 2, 3, 4 and 5. Because there are total 5 numbers. So 5 denominators. It means it is parting the integers 0 to 1 by the 5 parts. And here we have just parted into the separated made the parts by the 3, 3, 3. Okay, as well as on the left hand side, that's the 3, 3, 3. Now again one more example for you. Here let's represent the number 2 by 9. 2 by 9. Okay. So as usual, as we did here, we will do the same process, but let's take here minus 2 by 9. Okay. So that will be more better. Okay. One positive one, one negative one. So let's start with the 0. So here let me select 0. Then actually 0 by 9. So 0 by 9, minus 1 by 9, minus 2 by 9, minus 3 by 9, minus 4 by 9, minus 5 by 9, minus 6 by 9, minus 7 by 9, minus 8 by 9. Okay. And on the right hand side, all the positive numbers like 1 by 9, 2 by 9 and 3 by 9. No need to write this, but for your reference I am writing the positive one, because I just have to show the minus 2 by 9. It means I just need the negative side only, the left hand side only. Now let's identify minus 2 by 9. Yes, it's there. Here that's minus 2 by 9. So here we have the represented minus 2 by 9 on the number line. Now again let's check that the parts are correct or not. So we just have to calculate the total 9 parts, because there is the sign that is 9. Okay, the denominator that is 9. But for that I have to write one more number to just minus 9 by 9. Okay, that is for your better reference. Let's check now. We'll start with here. So here that is from 0 we will check. Okay, from 0 to 1 we have to go, and so between 0 to 1 there should be 9 parts. Let's check. Here 1, here is 0. Okay, 1, 2, 3, 4, 5, 6, 7, 8 and 9. There are total 9 parts. And this is 1. Yes, actually 9 cancels, so that will be minus 1. So here is minus 1 and there is 0. In between there are total 9 parts, because we were representing the actually minus 2 by 9 and denominator is 9. It means we are just making the parts by the 999. Okay. So this is how we can represent the rational numbers on the number line. After this we are just going to start the next exercise, but before that just pause the video and note it down. So now let's start exercise 1.2, the question number 1. In that we have the two different numbers, 7 by 4 and minus 5 by 6. So both the rational numbers we have to represent on the number line. So let's start with the first one, that is 7 by 4. Okay. So as we have discussed, first of all what we will see? We will see the denominator, that is 4. It means on the number line we will write each and every number with the denominator 4. So here that is the positive ones, it means we need the positive numbers more. So we will start with the 0. Here that will be minus 1 by 4. Okay. On this side that will be 1 by 4, then 2 by 4, 3 by 4, 4 by 4, 5 by 4, 6 by 4, 7 by 4, 8 by 4. We have to represent 7 by 4 on the number line. Here, see, here is the 7 by 4. Okay, so that's clear. Now, the second one, that is minus 5 by 6, we have to show. So it means denominator is 6, so we will write each and every numbers with the denominator 6, fine. And we have to go till minus 5 on the left hand side. It means I should write 0 anywhere here. And there is the denominator is 6, it means we will write like 1 by 6. And you can write 0 by 6 also. 2 by 6 and 3 by 6. On the left hand side, negative numbers, minus 1 by 6, minus 2 by 6, minus 3 by 6, minus 4 by 6, minus 5 by 6, minus 6 by 6, minus 7 by 6, and minus 8 by 6. Fine. We have to go till minus 5 by 6 only, but I have written till the minus 8. Okay. Generally, if you will write till minus 6 by 6, that's fine. No need to write more numbers. Here we have to represent minus 5 by 6, which is here. You can see. Okay, that's the minus 5 by 6. So this is how we can represent the rest of numbers on the number line. Now just pause the video and note it down. In the question number 2, we have to represent minus 2 by 11, minus 5 by 11 and minus 9 by 11 on the number line. Okay. Now, first of all, let's think that can we represent these three numbers on a single number line, or we need three different number lines to show these numbers. So yes, we can show this all the numbers on the only one number line, because see the denominator, there is 11, 11 and 11. All the denominators are same. It means we can show all three numbers on the same number line, and suppose these all three denominators are different, it means we need the three different number lines. But here we can show these three numbers on the same number line, and all the numbers is negative. Okay, it means I need more space on the left hand side, because the negative numbers that will be on the left hand side. So let's start with the 0 that can be here, and denominator is must be 11. So here 1 by 11, 0 by 11 can be written, then 2 by 11. Okay. For 0, there is no any special need, like it should be written as 0 by 11 only. If you are writing 0, that's fine, there is no problem, because 0 by 11 is 0 only, and if you will write 0, that's then again that's 0 only. So now I need to move towards the negative side. For the left hand side, minus 1 by 11, minus 2 by 11, minus 3 by 11, minus 4 by 11, minus 5 by 11, minus 6 by 11, minus 7 by 11, minus 8 by 11, minus 9 by 11, minus 10 by 11. Okay. Now there is no need to write minus 11 by 11, because the maximum number, that is 9. Okay, so it's written minus 9 by 11. Now just I have to point out these all the rest of numbers, so we can just show them by doing the circle on the number line. The first one, we are just starting with the minus 2 by 11, which is here, minus 2 by 11, then minus 5 by 11, which is here, and minus 9 by 11, that's here. Okay, so here we have shown the three different numbers on the same number line. Okay, because the denominators of all the numbers, that is same. So here the question number 2 is done. Just pause the video and note it down.